don't do the plus signs. Yep, we just list it right after the other. Don't do commas. Just list them. Yeah. That's S2. Wait, I don't get that. Wait. Yes. Two commas. Oh, yeah. Just have to I don't get that. How is it S? Is it S1?
Yeah, and then there's S2.
So it's one S1 first.
One S2. You stop at work?
But that's the one.
So this is your run. Like that's your but that's what's going on.
Oh, you're going here S.
So like, and then you go down. You stop at the line.
Two S.
And then now you go down here. Two.
Oh, so it's two. All right. Did you get it? Ashley. Did you get it? Okay. Now, I want to ask you something. What ion does calcium form? What ion does calcium form? I won't have a guts to do that again. Y'all. What ion does calcium form? What, Chase? You know. I can see it in your face. You don't. Where is calcium? It's number 20, right? What ion does it form? Plus 2. Oh, that. Yeah, that. Okay, so calcium forms a plus 2 ion. So on the test, when I say, give me the electron configuration for the calcium ion, you're going to know that that means calcium with a plus 2 charge. Yes? Yes? Why not? Because it's in the second column, and all those second columns, when they form ions, form a plus 2 ion. Yep. Yes? Well, hold on. I haven't gotten there yet. You're okay with calcium forming a plus 2? Yeah. Okay, now, the electron configuration for the calcium ion is not going to look like this. Don't use the back of the marker, baby. It scratches the finish. Use a paper towel. So, calcium ion is going to look a little different. Why? Well, what has happened when it formed a plus 2 charge? Literally, how did it get to a plus 2? What? 2 electrons? Lost 2 electrons. Good. All right, so calcium will no longer have 20 electrons. It's only going to have 18. And so what are you going to do to give me calcium's ion? You're going to back up 2 spaces. That's all you're going to do. You're going to back up 2 spaces and write the electron configuration for that. So calcium is here. So backing up 2 spaces, losing 2 electrons means it's going to look like argon's configuration. And so calcium plus 2 is going to look exactly like neutral calcium, except it's going to not have the last 2 electrons. Done. Does that make sense? Let's do oxygen. I don't know why I said it like that. Oxygen. As soon as you get it done, look up. I'll have the answer up here. Neutral oxygen. So there is neutral oxygen. You good with that? Okay. When I say the oxygen ion, what does that mean? Oxygen with what charge? -2. Y'all need to review your oxidation numbers, yo. Okay, so what does that mean? It is gained 2 electrons, so you're going to move forward 2 places. 1s2, 2s2, 2p6. Done. Okay, why do elements form ions? Why? Because they want to what? Not neutral, that's why they bond. Why do they gain or lose electrons? To be full. Good. Who is full on the periodic table? Always? Oh. So you're always going to end up with a noble gas configuration for an ion. So for a charged particle, it's always going to be a noble gas configuration. Because that's the only reason they become charged, is so they can feel like a noble gas. Does that make sense? Yes-ish? Okay. There's a few practices for you on that worksheet when we get there. We're not there yet, though. All right. So I have just finished electron configuration. The full electron configuration. So I've taught you this. I need to teach you 3 more skills, and I'm going to give you a heads up. The skills that I'm about to teach, here are the skills. The skills that I'm about to teach, students get these mixed up. And so I ask for noble gas configuration, and you give me, I don't know, orbital notation. And so you get it wrong, not because you don't know how to do it, but because you answered the wrong question. So, helpful hint, when you're studying for this test and for the quiz on Tuesday, make sure you know what these phrases mean. Okay, focus on those, because I know you'll know how to do the skills. They're easy. But when I ask for noble gas orbital notation and you give me noble gas electron configuration, and you're going to get it wrong. So you've got to concentrate on what these mean. All right. So let's start with noble gas configuration. So yesterday's notes, let's add this to yesterday's notes. Noble gas configuration means you get to jump to the closest noble gas before the element you want. Okay. So when I ask for noble gas configuration, you get to do this. And it's only when I ask. So you can't give me noble gas configuration just because you want to, because it's easier. Because it is. It's significantly easier. All right. Or shorter, at least. I don't think it can get any easier. All right. So let's do the noble gas configuration for iron. And so we're going to tell the reader that we're going to iron the same way. We're going to put iron symbol, colon. But then you get to skip ahead. Remember I told you yesterday one of the rules is you have to go in atomic number order? When I ask for the noble gas configuration, I am giving you permission to skip ahead to the closest noble gas before the one you want. So what is the closest noble gas to iron? So argon is the closest right here, right? Argon. Why don't you use krypton? It's actually a little bit closer by distance. It's after. So it doesn't do you any good to start after the finish line. Here is your finish line. So you want to start before the finish line. All right, so we're going to tell the reader that we're going to start at argon by putting argon in brackets. So you're going to put argon in brackets, and then you're going to start from there. What's after argon? 4, S, 2, and then 3. Which way is a 3? 3, D, 6. Oh God, which way is a 6? There. Easy? Easy. The only time you can do this is when I've asked for the noble gas configuration. So argon 4s2 3d6. All right, so if I ask for the noble gas configuration for tin, number 50, which noble gas are you going to use? Krypton. Number 50? So the closest one is number 36, krypton. Good. If I ask for iodine, number 53, what's your noble gas? Krypton. Okay. You good with that? Simple. All right, so that is noble gas configuration. The only time you can give me that shortcut is when I say these words. Noble gas configuration. Yes. Yeah, it's 4s2 3d6 with argon in brackets. All right, let's try orbital notation. Orbital notation is going to require another page of notes. They're not long, they're just roomy. Orbital notations, here you go. how did I know how many blanks to draw under each of these? Yeah, but how do I know the number of orbitals? I mean, I know it because I'm incredibly smart and well educated. But how could you people know how many orbitals are in each of these? What's the easiest way to remember how many orbitals each sublevel has? How many pieces each sublevel has? By the total electrons that can fit in each, right? All right, so a p sublevel can hold how many? How many total electrons? 6, good. And if each of those pieces can hold 2, that means you need 3 blanks. D can hold 10. Each one can hold 2. That means you need 5 blanks. Yes? Okay. Another way that students are remembering it is just 1, 3, 5, 7, or the first odd numbers. Whichever way works for your brain. Okay. So now we're going to learn how to use these, but before we do, I want to reiterate to you, an S always gets 1 blank no matter what, forever and ever, amen. P always gets 3, period. Even if you're not going to use them all, you're still going to draw 3 blanks. So D, even if you only use 3 of these blanks, you're still going to write 5 of them. And I'm going to show you exactly what I mean by that. All right, so before I do, let's write the electron configuration for sulfur. So write that real quick and then look up when you're done. Did you get it right? Good. All right, now we're going to use that to write the orbital notation. Now, I get students all the time, because orbital notation is harder to visualize, I get students all the time who write the electron configuration first and then give me the orbital notation, and you can do that on the test or quiz, and you'll see why some students do that. It's really, it helps make sure that you're doing it right. But if you do that, please make sure that you tell me which one you want me to grade by either crossing off the wrong one or circling the right one or something. Don't leave both on there. So if I ask for the orbital notation and you give me this electron configuration first to write the orbital notation after, that's fine. Just cross it off when you're done or circle this one because I need to know which one to grade. Okay, so you'll see why it's an advantage to have these two right next to each other. So I'm going to write sulfur just like normal. But instead of 1s2, I'm going to write 1s, and then above it, I'm going to write a blank. And then how many arrows am I going to put in that blank? 2. 1 up and 1 down. Why? There's 2 electrons. That's what the arrows represent. And then the electrons within those orbitals, they spin in opposite directions. So this is telling the reader that you know they spin in opposite directions. It seems like a little bit of a detail. It's like, yeah, who cares? Nobody cares until you get to college. Once you get to college, then this actually tells you really useful information. It doesn't until then. Yeah. No, it doesn't matter if up is first. I always do my ups first, then my downs. Let's just have it. Okay, next. So we just did 1s2. Now let's do 2s. It's going to look exactly the same. It's just going to have a 2s underneath it with an up and a down. So do you see how these superscript numbers right there represent these arrows? So you're just rewriting the exact same information, just looking in a different way. All right, so next we're going to do 2p6. How many blanks do I write? 3 blanks. Underneath them, write your 2p so I know which orbital they're in. And I'm going to write how many arrows? 6. This is a helpful hint, and I strongly recommend you follow it. You're not going to get it wrong most of the time, but the one time that you forget, you'll probably get it wrong. So I always go through and draw my ups first, and then I backfill my downs. And the reason I do that will become obvious here in a second. So I'm going to go through and put in my ups, 1, 2, 3, and then I'm going to put in my downs, 4, 5, 6. It doesn't change anything until it does. And I'm going to show you that in just a second. Okay, next is 3s2. So how many blanks? 1, 3s underneath, an uppie and a downy. Last is the 3p. How many blanks? 1, 2, 3 blanks with a 3p underneath. Okay, here is where, if you're not careful with your arrows, you could get it all wrong. All this work for nothing. This is wrong, and I'm going to put it in red or pink, because I'm going to erase it. I'm going to put my 4 arrows in here, and I'm going to do it wrong. 1, 2, 3, 4. It's wrong. It's wrong because you're telling the reader that these electrons are cramming in right next to each other instead of spacing out as much as possible. And so electrons don't fill like that. They fill like this. They fill the first orbital, then the second, then the third, and then if you need more electrons, they backfill over here. There's my 4 electrons. And that's the orbital notation for sulfur. Same information, a little bit more detailed. Just FYI, the reason this is helpful is when you get to college and you start studying orientations of these electrons in space. This is the x-axis, this is the y-axis, this is the z-axis, and so they can specifically tell exactly where each electron is based on this notation. And you can't do that with this. So that's why it's useful to people who care. All right. Do you think you know how to do the noble gas configuration? Noble gas orbital notation? Yeah, I bet you do. It's going to look exactly the same as the noble gas configuration for sulfur. It's just going to have arrows and blanks instead of just letters and numbers. All right, so what noble gas are we going to do for sulfur? Is that right? Neon? Yep, neon's before sulfur. Good. All right, then you're going to go from there. What's after neon? Three S2. So I'm going to draw my 1 blank and put 3s underneath it and put my 2 arrows, 1 up, 1 down. What's next? 1, 2, 3. 3p4. Uppie, 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 and then 1 down, and you're done. Oh, I'm sorry. No, you don't. Simple. Can you see, though, how easy it would be to mess up and give me the wrong one? Yeah. And so there's only so many different ways I can make this difficult and pre-AP level. And so I've tried to think of every way that I could possibly ask you a weird question on the test or quiz, and I've put it on this practice. So you will see these questions on the test or on the quiz, and on the quiz. So I want to make sure you have time to practice that. You're going to have the rest of the period today and most of the period on Monday. We're going to learn something else on Monday, but it ties in very, very easily. So everything should be all nice and wrapped up before your quiz on Tuesday. Okie dokie. The key is up here. It's also on Canvas, but it's up here. You have the rest of the period.